So hello everyone, welcome to the channel. So in this video, I'm going to show you the methane pollution monitoring using Sentinel-5P Imagery for any study region in Google Earth Engine. So now let's get started. So methane is one of the most potent greenhouse gases, significantly contributing to global warming and climate changes. It is released from various anthropogenic and natural sources, including agriculture, livestock farming, landfills, wetlands, and fossil fuel extraction. Monitoring methane emission at regional and global scale is essential for understanding the emission patterns and assessing the environmental impact and implementing the mitigation strategies. The satellite-based remote sensing, particularly using Sentinel-5P imagery, provides a reliable and efficient approach for a large-scale methane monitoring. The Sentinel-5P satellite is launched by European Space Agency, carries the tropospheric monitoring instrument, which detects a methane concentration in atmosphere with high spatial and temporal resolution. So in Earth Engine, we can perform the geospatial analysis at global scale, and we can perform time series analysis of this methane level across different regions. So in this study, we're going to analyze the methane pollution over any study region by processing the Sentinel-5P methane dataset from 2019 to 2024. So the study focuses on extracting the monthly average methane concentration and visualizing the long-term trends and exporting the methane data for further analysis. So let me get back to Earth Engine. So to assess the methane pollution over any study region, first we have to define our region of interest. So to define our region of interest, we're going to navigate this option called draw a rectangle. So now we're going to we're going to create a study region over any part of the world. For example, we're going to focus specifically on this particular region, that is Thailand. So I'm going to create my study region. So once we created a study region, so let me turn off the layers here. So you can able to visualize we have created a study region here, and let me click exit. And now once you created a region of interest, so here a variable called geometry will comes up here, polygon 4 vertices. So here I'm going to click this option called show generated code. So here you can able to visualize we have the latitude and longitude of the study region. So I'm going to copy this latitude and longitude of the study region here using Ctrl C in your keyboard. And I'm going to paste my latitude and longitude in this variable here using Ctrl V option in your keyboard. So we're going to define a variable called study area coords, represents study area coordinates. So in that we have pasted our latitude and longitude of study region. Next we're going to convert this coordinates into a geometry polygon. So we're going to convert this latitude and longitude into a polygon. So for that, we're going to define another variable called study area equals to earth engine dot geometry dot polygon study area coords, that is coordinates. And to center this particular study boundary, so we're going to define map dot center object study area with a suitable zoom level of 5. And to add this layer, we're going to define map dot add layer study area. And in the visualization parameter, I'm going to mention the color as black color. So for the study area visualization, and we can output the name as study area. So let me navigate this option called run script. I'm going to turn this off. So now here you can able to visualize in the layer section. We have this layer called study area. And next we have to load and process the methane data. So we're going to perform a time series analysis for this particular using this particular data set. So first we have to define our start date and end date. And before that, let me explain about this particular dataset. So Sentinel-5P offline CH₄ offline methane. So the dataset availability is from 2019 to 2025, and the dataset provider is European Union, ESA, Copernicus. And using this particular code, you can access this methane dataset. And this is a global level dataset which is available from 2019 to 2025. And the resolution of this particular dataset is around 1000 meters. And these are the variety of bands that is available in this dataset, starting with CH₄ column volume mixing ratio, DROIR, so which is represented in this particular unit called mole fractions. And the description about this data is column average DROIR mixing ratio of methane as a part per billion. And we have another band called aerosol height and aerosol optical depth and sensor azimuth angle and sensor zenith angle and solar azimuth angle. And we have this variety of different layers, that is bands, that is available in this data. So specifically, we're going to use this particular band called CH₄ column volume mixing ratio dry air. So the units is in mole fraction and the minimum and maximum values. So let me get back to Earth Engine. So before we're going to load and process the methane data, we have to fix our timeline. So the dataset availability is first from 2019 to 2025. So our analysis period going to start from 2019 to 2024. So in the variable start year, I'm going to mention as 2019 as the start date of the analysis. And the variable, I've created another variable called end year, where the end of the analysis is 2024. So in the next step, we have to load our Sentinel-5P methane dataset into Earth Engine. So for that, we're going to create another variable called methane collection equals to Earth Engine.image collection Copernicus S5P offline L3CH4, that is methane. So using this particular code, we can access the methane Sentinel-5P dataset. And from this dataset, we have already shown you we have this variety of different bands that is available in this particular dataset. So in order to selectively select this particular band called column volume mixing ratio dry air, so we're gonna use this particular function called .select function, and we're gonna specify the band name, that is CH₄ column volume mixing ratio dry air. So once we selected this band, next we're gonna filter based on our previously mentioned the date, start and end date. So we're gonna filter based on the timeline of our analysis using .filter date function. So I'm going to specify my start year and I'm going to specify the end year. The start year is around 2019 and the end year is around 2024. And last, we have to filter it based on a region of interest. So our region of interest, we have created this particular study region as our region of interest containing Thailand, Cambodia, Vietnam. So these are the study regions. And next, so we're going to apply this filter bound function based on the study region. And next, we have to generate a list of years and months. So in the next step, we're going to generate a list of years and month. So to do that, first we have to define a variable called year list. So first we're going to generate the year list for our analysis years. So for that, we're going to define a variable year list equals to earthengine.list.sequence bracket earthengine.number.parse. So basically this function converts the string into a numeric type. So that's why we're using this here. And the start year, which indicates that this particular is our start year, that is 2019. And earthengine.number.parse. So similar, it's going to convert the string into a numeric type. So in the end year, that is 2024. And last we mentioned .subtract 1. So it's going to subtract 24 minus 1. So the analysis period will be from 2019 to 2023. So in the next step, we're going to define another variable called months list equals to earthengine.list.sequence 1 to 12. So the 1 to 12 here represents January to December. So now we have generated our list of years and our list of months. So next we have to compute the monthly average methane concentration. So to do that, we're going to create a loop function. So first we're going to define a variable called monthly CH₄ equals to earthengine.image collection year list.map function year. And basically this code loops through each year in the year list and each month in the month list. And it's going to return month list.map function month. So we're going to create another loop, and inside the loop we're going to create a variable monthly image equals to methane collection, referring to a Sentinel-5P image. So you can able to see here. And inside we're going to filter, we're going to apply some filter. So we're going to filter it by year. So to do that, we're going to apply .filter earthengine.filter.calendar range. So the start year and the end year and the unit in year. So we have filtered it by year. Next, we're going to filter the methane collection based on month. So to do that, we're going to define .filter earthengine.filter.calendar range in calendar format, and start month and the end month and the unit of the month is month. So we have now filtered it based on month. So the start year is 2019 and the end year is 2024, and the start month is January and the end month is December. So the start month is it is January and the end month is of December. Similarly, the start year is 2019 and the end year is 2024, and the start month is January and the end month is December. So for each month pair, it filters the methane collection, keeping only the images from that year and the images from that month. And last, we're going to compute the monthly mean. So to do that, we're going to define dot mean function to compute monthly mean methane concentration. So in our next step, we're going to create a timestamp. So for that, I'm going to create a variable called timestamp equals to earth engine dot date dot from year, month and day. So year, month and day. So generates a timestamp. So this sets the first day of the month as a reference for the time series analysis. So next we're gonna return the monthly image dot set system time start and timestamp dot millisecond function. So to convert to a millisecond format. And last two is we are applying the flatten function. So the flatten function is used to convert it into a single image collection. Each image represents the mean methane level for the specific month. And last, to display the mean methane concentration layer, so we're going to define a variable called CH₄ equals to, we're going to set a minimum of 1750 and maximum of 1900 based on the minimum and maximum values. So the minimum value is around 1285 and the maximum value is 2405. So you can set this maximum value according to this range here. And we are applying some color palettes to it, starting from black, which indicates the lowest methane concentration, and towards red, which indicates the highest level of methane concentration. And last, to add this layer, we're going to define map.addLayer monthly CH₄ referring to our the loop functions we have created here. So to compute monthly average methane concentration, and we're going to apply the mean function here, dot mean function, to compute the mean methane concentration. A mean methane concentration for the entire timeline from 2019 to 2024. For that, we are applying the dot mean function and dot clip based on our region of interest. And CH₄ represents the visualization parameter. And we're going to output the layer name as average CH₄ concentration. So it's going to output the layer name as average CH₄ concentration. Average, which indicates the we are extracting an average methane concentration from 2019 to 2024. So next, to perform the time series analysis, so to create a time series chart for this methane concentration for this study region, so we can define print ui.chart.image.series image collection referring to a monthly CH₄, that is monthly mean methane concentration, mean methane concentration, and the region we define this study area, that is this study region, and we are applying the statistical operation earth engine.reduce.mean function in order to compute a mean methane concentration. And the spatial resolution we are setting to 1000, and the spatial resolution of the Sentinel-5P is around 1000 meters. So you can also set this value to 1000 meters. And in order to compute increase the speed of computation, I've set to around 7000. And the properties of we define systems time start, that is 2019. And you can also set other options to this chart, time series chart. So for that, we're going to define set options title monthly CH₄ level 2019 to 2024, and the v-axis we're going to define CH₄ concentration ppb, that is in part per billion, and in the h-axis title is year, and the series we're going to give it 0, and the color of this chart, the line we're going to specify as red, and the point size of the point we're going to specify as the 4. So the point size which represents this particular one here. And to extract, suppose if we want to visualize the methane concentration only for 2020, so in that case, to extract the methane for 2020, we're going to define a variable CH₄, 2020 equals to methane CH₄. So to extract the methane for 2020, we're going to define variable CH₄, 2020 equals to monthly CH₄ dot filter date. So we're going to apply filter date function to extract this on this particular year, that is 2020 January 1, 2020 December 31st. So in order to acquire the mean image, so we're going to define dot mean function, and to add this 2020 methane concentration to earth engine, we're going to define map.addLayer CH₄ 2020 dot clip based on our region of interest, that is study area, and this visualization parameter referring to CH₄, that is we have previously created the visualization parameter here. So referring to this particular variable CH₄, and output the layer name as CH₄ 2020. And last, to export this image to a Google Drive, so we're going to define export dot image dot to drive. An image you're going to specify CH₄ 2020 dot clip, that is our based on a region of interest, that is study area. Description CH₄ 2020 mean, and the scale, that is spatial resolution. So to export this image to a drive, make sure that the resolution is set to 1000. So the resolution of this particular data is around 1000 meters. So I've set this resolution to be around 1000, and the region is our study region. The max pixel value 1:10^13, and the folder and the coordinate reference system is EPSG 4326. And now let us visualize the image here. So we're going to navigate the layer section. Let me zoom here. And the layer, we're going to turn on the average CH₄ concentration from 2019 to 2024. So let us visualize it. So first let us take a look at the average CH₄ concentration. So you can able to view from this image here. So the red, which indicates the highest level of methane concentration in the study region. So you can able to visualize based on our visualization parameter here. So red, which indicates the highest level of methane concentration, and the black, which indicates the lowest, and the green, which indicates the moderate level of methane concentration. So over the study region, you can able to visualize the highest level of methane concentrations observed in this region. So you can also navigate the layer section here, and we can click this option. And here, so the value ranges from 1750 to 1900. So in the custom option, we can apply this stretch 90%. And now let us visualize the result. And now after applying the stretch 90, the value ranges from 1844 to 1941. So we're going to click apply, and let us visualize the result for average methane concentration on the study region over the period of time from 2019 to 2024. So now you can able to visualize this image here. So based on our color, so after applying the stretch type, the current stretch type of 90%, so you can able to visualize here the red are indicated in the central part of the study region, so which indicates the highest level of methane concentration. Comparatively, the blue, which indicates the lowest methane concentration based on the color palette here. So you can able to visualize towards the southern part, southeastern end and western part of the study region has a lower methane concentration compared to the northern part has a higher level of methane concentration in the central part. So you can able to see that. And similarly, let us visualize the methane concentration for in 2020. Gonna turn on, and I'm gonna turn this off. And similar, I'm gonna apply 90% stretch, and so in the custom section, I'm going to select stretch 90% and let it load. And now we're going to click apply. So the value ranges from 1824 to 1936. So now in the image, you can able to visualize only the northern part of the study region has a higher level of methane concentration, and the central part of the study region has a more methane concentration compared towards the eastern and western part has a lower methane concentration. So in 2020, so we're going to close this, and let us take a look at the time series chart here. So I'm going to click this option here, and this is our monthly methane level in the study region from 2019 to 2024. So you can able to see here, so in this particular time, that is in 2019 January, the concentration of methane is around 1860.97 part per billion, and it was comparatively low during July, so it was around 1826.83 part per billion, and the highest value were observed in this year, that is in 2022 September, was around 1952.993 part per billion. And this particular year, we have this the concentration of methane has dropped during in the month of July. The similar trend is observed here. July, the methane concentration has dropped, and similar trend here in July, the methane trend has dropped in the study region. So you can able to see that particularly in July, the concentration of methane trend has been dropped in the study region. So you can able to see, and the peak level of methane concentration rose during the month of October. And let me check here in the month of October, and October. and also in September, so in 2022. So you can able to see the methane concentration rose in the month of September and October in the study region, and dropped during the month of July. So let me get back to Earth Engine. And in the last part, to export this image to your Google Drive, so we're going to click this option called task section here, and in that we have this option called unsubmitted task. So CH₄ 2020 methane. So we're going to click this option called run, and a new window pop up saying initiate image export. And now to export this image to your Google Drive, so we're gonna select drive and make sure this resolution is 1000. The coordinate reference system is EPSG, and the drive folder and file format is GeoTIFF. And once you did that, we're gonna click this option called run to export this image to your Google Drive. So I'm gonna cancel this, and let us take a look at the application part of this particular so the application is the climate change studies. The methane is a major contributor to global warming. So the monitoring CH₄ level helps in assessing its role in climate change and developing strategies to reduce the greenhouse gas emissions. And second is the emission source identification. So the satellite-based methane monitoring can identify the emission hotspots such as the industrial sites, oil and gas field, and landfills, aiding in regulatory compliances and pollution control. And agriculture and wetland studies. The methane emissions from rice paddies, livestock, and wetland can be quantified to be assess the impact on atmospheric CH₄ levels and improve the sustainable agricultural practices. And air quality monitoring. Elevated methane level can contribute to a poor air quality. So continuous monitoring helps in understanding regional air pollution trends and mitigating the health risk. And in energy sectors, so high resolution methane datasets can be used to monitor the leaks from the natural gas pipelines, and coal mines and oil extraction sites can be detected and monitored, helping the energy companies to reduce the wastage and improve the efficiency. And last is the disaster and environmental risk assessment. Sudden spikes in methane emission may indicate environmental hazards such as underground gas leaks, volcanic activity, or the permafrost thawing in Arctic regions. So in this video, I have shown you methane pollution monitoring using Sentinel-5P image for any study region in Google Earth Engine. So the link for this code will be given in the description section of this channel. So thanks for watching, and make sure that you subscribe to our channel and give us a like.